Welcome to CS 2700 Programming and Data Structures. This for non-CSE students, which means that if by mistake somebody from the CS batch has joined this class, uh, I think you should be aware that your class is going to be in C slot, the CS students. So you should probably leave this and join the class by Dr. Meghna. All right. My name is Rupesh, and I'm going to be with you in this journey of programming and data structures. The course webpage is given at this link. All these slides will be made available on the course webpage, but you must have received an email from me mentioning what this link is about. So most of the information related to the course is going to be available here. Many of the discussions about the course are going to be on Moodle. And by default, you are unlikely to get subscribed to this Moodle link. So you need to do it manually. I have enabled student enrollment, self-enrollment, and therefore you should be able to enroll yourself. If you face any trouble, just mail me. We have a few TAs for this course: Abhishek, Kaushal, Lokashi, Shan, Solarika, Akshay, and Keshav. Those are going to be helping us evaluate your assignments. Okay, so let's get started. If you look at the overall placement of this course in computer science and engineering, then I'm going to show you what are the other courses which fit into this overall curriculum, especially the core courses, and then where this PDS fits in. So in the first year, computer science students do this CS 11, now it is called 1111, but all of you must have done this CS 1100, which primarily deals with the coding part. CS 1200, which is discrete mathematics, talks about proofs, talks about counting. So those are the primary aspects that students learn in discrete mathematics. In contrast to more like an analog mathematics, continuous mathematics, which we have been studying in, let's say, 11, 12 standard or even after coming here. In the second year, students learn a variety of different aspects of computer science. 2200 is languages, machines, and computation, which talk about what things are possible to be done by computers, as well as amongst the parts which are possible, what parts are going to be easier versus let's say difficult by some other computation. So that happens in languages, machines, or computation, which is also called as theory of computation. 2300 is about the foundations of computer system design, which is more like how the gates, how the different flip-flops, etc. work, more on the lines of switching theory, which many of you might have done as part of your curriculum. 2600 is a little higher up, more closer to what we see as the computer hardware, which is the computer organization and computer architecture. 2700 is about the efficient implementation of the different procedures that we want to implement on a computer, which is this course. 2800 is in the next semester, which is about the algorithms. Once you know these data structures, then algorithms are going to make use of these efficient data structures to implement your codes. In the third year, students learn different ways of programming in paradigms of programming, for example, functional and logic. They also learn object-oriented programming as part of 2810, which is also in the second year, that is the fourth semester. 3300 is compiler design, where we learn about the translation from program to a machine code. And 3500 is operating systems, which is talking about the resource management inside the hardware, because we are interacting with the hardware via the operating system, right? So your Windows, Linux, Mac, OS, etc., or even Android, all of these are different operating systems. So briefly, this comes in the middle of your computer science curriculum. So you need to know a little bit about earlier courses, and you are going to feed this course into many other courses. Now, 1200 proofs and counting or discrete mathematics is a prerequisite for this course, and that's one of the reasons why many of the non-CS students have not been able to take it. So what we have done this time is that we have tried this on an experimental basis, that we will uh, allow students who have even not done discrete mathematics but have done basic coding, let them take this course and let's see how it goes, right? So depending upon how your feedback is, what parts you find difficult, what parts you find easy, this course might get modified, and if there is interest next year by the department, then this might continue for some time. But yeah, that is going to be decided by the DCC. All right, so any questions so far? All right. So let's move ahead. I'm going to kind of motivate programming and data structures with an example. I suppose since you have done programming, you will know the importance of programming anyway, but I'll motivate the importance of data structures with an example which we all are aware of, right? So let's say you have this Ola, Uber kind of taxi service, and what you want to know is, let's say there is a taxi or an auto which is going to be around you, right? So you want to know if there is a taxi around, or as an app developer, you want to find out what taxis exist around you, right? So if you look at different courses that happen, and don't worry if you have not done some of these courses, that is more for me to bring you to the overall uh, kind of, let's say, the scheme of things about different courses, right? So for example, in discrete mathematics, we might ask how many ways can you go from, let's say, IIT Madras to the Chennai Central. In LMC, can you compute a particular aspect using a smartphone? Right. So the decision version of the problem might come into play when we are talking about the languages, machines, and computation. In case of computer organization, computer architecture, you can talk about how to build a smartphone hardware which can run all these apps. Right. In PDS, you will ask some question like this: that how to keep track of the cabs around you, such that a passenger can query the nearest cabs efficiently. Right? This word efficiently is going to be one of the primary concerns throughout this course, and that's one of the kind of driving factors for designing newer and newer data structures. So that is going to be a primary goal for us. In case of other subjects, you will ask slightly different questions. For example, in algorithms, you will ask how to compute the shortest path from IIT Madras to Chennai Central, right? And that shortest need not always be in terms of the distance. It could as well be in terms of time. It could be in terms of traffic. It could be in terms of I want to maximize the number of highways, etc. In case of operating system, you have to worry about different resource management. So for example, if I'm into an Ola app and an incoming call comes, how do I give priority to an incoming call, right? Because the screen is showing something else, right? These things we start taking for granted as we start using these devices, but there is somebody else, right? Some other developer or a set of developers who are sitting in the backend and doing all of this for you, right? We would like you to become those developers who are providing service, who are providing products to other people, right, at the end of your BTech. Then compilers is going to talk about how to translate that app which you are writing in an Android, let's say, Android programming, to a machine code which the hardware can understand. In networks, how does a phone call work? I'm calling, let's say, the driver, or even there is a communication happening when I am talking from this mobile phone to the server where all this information is going to get stored, because not all information is on your mobile. Then in case of database management systems, I'm going to store and retrieve this world map data relevant to the user and show only the relevant portion to it. So how to retrieve that data efficiently. All of this is going to be applicable in the context of databases. Does that mean that all these courses are going to be very different? Yes, their emphasis is going to be different, but do not decouple these subjects, right? So some of you might be doing some of these courses as part of your free electives. So do not decouple these courses. The knowledge of one course is going to feed into the other. And in fact, you should even try to look at it in that manner. In the context of PDS, the algorithms course is going to be very relevant, and depending upon whether it is permitted or not, you should try to take algorithms course either in CS department or elsewhere. So these courses go hand in hand. It's just that we emphasize on one hand at a time. Right? So just to illustrate a little more that in the context of PDS, are there other questions that we need to worry about, right? So this is the question that we talked about. There could be others. For example, how should I store the addresses? So such that when I'm typing this address, for instance, currently it shows 18 Cross Road, MG Road, etc. Right? So I might be typing this address, which is my current location, or I'm typing the address of Chennai Central. So how should the app store or even the server store these addresses such that as the user is typing, the app can show these suggestions, right? So that requires you to store and efficiently retrieve this information, and that also is part of the data structure. How should I categorize the cabs such that the passenger is able to view different kinds of cabs quickly, right? So there are micro, mini, prime, whatever sharing options available, etc. So these aspects also come into how you organize the data, how you organize all the information that you have, which is coming from different cabs, which is coming from different passengers. How do I quickly identify if there are multiple sharers nearby? I'm going to go from here to Chennai Central or here to, let's say, some mall, and maybe there are other students who want to go from here, right? So you're going to a mall on a weekend, well, in the physical world, let's say, when you all will be here. But if you have that, why not share the cab if you are anyway going alone, right? So all of these are different ways in which you need to organize data. Then graphics rendering is another information, another problem that might come into picture. So your application might demand something, but that requires you to organize the data such that that application is able to get this information fast. So think about data structures as an assistant. Let's say there is a cook who is doing something, and that assistant is going to give the information quickly, give the all the ingredients that are required for cooking quickly. That cooking is your algorithm, is your application, right? So yeah, I have mentioned a few of these. Any questions so far on these ones? Okay. So if you have any questions, feel free to ask either by unmuting or by uh, using the chat box. I'll be happy to answer. I know in the first class it becomes a little difficult to ask questions, but yeah, feel free. Because this overall background information is also important, right? So I'll just mention this one point, that as there is more and more data, the data structures or how do you organize the data, that becomes more and more important. And these days, it's not only the data that is increasing, it's also the type of data that is increasing. For example, if you talk about, let's say, Facebook or your Twitter or Instagram, there is information about different people, but that alone is not sufficient. There is information about their age, gender, their location, their hobbies, their posts, their friends' information. So all of this is different type of data, and you would like to uh, categorize this information differently because you want to query based on certain aspects. For example, an advertising agency might be interested in figuring out which all people are kind of sitting at the boundaries of two, let's say, clusters of people. Right? This could be a query by an advertising agency because they want to minimize the number of places where they want to put an advertisement. Or you want to find out if there what is the distance between two people on Facebook or LinkedIn, right? So whether they are at a distance of 1 or 2, you must have seen this on LinkedIn, at a distance of 2 or 3 and so on. Once you know that, what is the path from where I can go? If I know some CEO of a company and I want to do an internship, is there a path such that I can go hopwise from one hop to another and reach that CEO so that I can get connected and send my CV. So all of these are real world problems, and all of these require that underlying data need to be organized in a particular manner. As we delve more into data structures, I would like to brush aside a few things, in some sense, misconceptions that some of us might have. Right. Uh, so first thing is that the data structures get created when we use struct. Right. So we all know about C++, that we are going to use struct to organize the data. Right. So and that actually creates the data structures. There is nothing like that. Struct is just one construct in C using which you will be able to well put related things together. Data structures also have some similarity with respect to that. So many times the data structures that we use are going to make use of the struct or class, but that doesn't mean that that is the only way. Right? Similarly, when you use struct, that creates new data structures, or that creates even good data structures. That is nothing like that. So these are overlapping, but these are not. There is no one-to-one correspondence between them. Right? For example, you can talk about arrays of primitive types. Those itself could be your data structure. Data structures need pointers, not necessarily, although most of the course is going to talk about a good deal of pointers, that doesn't mean that they need it. Right? Again, arrays is a good example, but you can have other examples. For example, even linked lists or trees or graphs, all of these you can create without using pointers. Right? So you can use some sort of an offset within an array, and that can act as, in some sense, a pointer. Right? So that is another misconception which you should remove. An algorithm which you want to use, or which your application is utilizing, that must use a specific data structure. No, that is not the case. Typically, the algorithms can use different data structures. I mean, for the same problem at hand, when you design an algorithm, you can replace a data structure by another one and still achieve the same functionality. Right? For example, if I might store all the information of students in a class in an array, or I might store it in a linked list, and I can still perform the same process. What will differ is not the functionality but the performance, and that performance is something which we would like to both quantify as well as qualitatively evaluate in this course, and we'll come to that as we go along. So an algorithm might use different data structures for doing the same process. C++ has more data structures than C, right? This is something which I have heard. There is nothing like that. All the data structures that we will see in C are going to be possible in C++ and vice versa. This misconception comes primarily because many of you might be aware that there is this STL, or standard template library, in C++, which allows you to have to make use of the existing data structures which are already there. For example, you have the list or vector or set and map and queues, etc. So all of these are already there in the C++ STL, and therefore one gets this feeling that these are all data structures. The data structures are in the implementation of these library constructs or templates. So, and all of these could be implemented in C. So that's not really, so data structures is, in some sense, yeah, to a good extent, it's a language agnostic, language independent aspect, which we are going to study. And there are in total 7 data structures. Well, there is nothing like that. It's just that there are some fixed data structures which are more like standard, which we usually study in PDS. But then there is a large set of other data structures which might be useful in specific contexts. When you write a particular application, you yourself might create different data structures. So that's possible. And then union find is the best data structure, right? So there is no such thing as a monolithic best data structure. Depending upon your application, depending upon your algorithm, you might use different kinds of data structures, and different data structures are good in different situations, and therefore there is no such thing as a best data structure. Anybody has any other misconception which you want to add? Maybe next time I teach PDS, I can add that to my slides. Anybody had this misconception some time back which you want to share? Okay, there is a question. First question from Soumya. Can all data structures in C and C++ be implemented in other languages like Python too? Yes. All of these are implementable in Python also. That's not an issue at all. And everything in Python can be implemented in C, C++. In fact, the backend of Python must have been written in one of these languages like C, C++. So the issue comes in when you have this notion of pointers and address taking, right? So as long as you support some sort of pointers in a language, you'll be able to implement most of this information. I mean, Python also has a lot of libraries related to lists, graphs, etc. So you can make use of those, but you can as well implement your own. That is also not a problem. Any other concerns? Anish has a question. Speed or performance of C++ versus Python? Yes. You guys should tell me. You guys are more aware of all of these aspects. Yeah. So this is one important reason why Python may not be the best language to implement some of these if you are worried about performance. When you are worried about fast prototyping, or you are not so much concerned about performance, it's okay to implement things in Python, MATLAB, such languages. But when it comes to, let's say, in some sense, high performance computing, or you're really interested, your company is, I mean, later when you join a company, your company is going to worry about, no, I want this to be implemented as well as I want good performance. You can possibly start with Python, but finally you would like to come to, let's say, C or C++.
Sir, you are muted. Can't hear you.
Thanks for that. Yeah. So let me try to reshare the slides. Yeah, so we were discussing about this. Yeah, I'm yet to share the slides. So we were discussing about the performance of Python versus C, C++. So if your company expects it to be implemented fast, which is always going to be the case, and you want it to be performance friendly, then definitely you will
So
have to.
slides are not visible.
Yeah, I am yet to share the slides. Please give me a minute. Right. So in that case, C, C++ is going to be your way to go. Any other questions? Any other concerns?
So what about Java and C++? Their performance.
Yeah, so a similar thing exists for Java and C++. So although Java has been optimized to a good extent, but then finally that virtual machine is going to come into play, right? And therefore there is a dynamic aspect of using Java at runtime. There is a virtual machine, right, which is running, whereas C, C++ it's running on bare metal on your machine, and therefore there is a performance penalty which Java virtual machine is going to give you. But then there are some aspects which are going to be very useful, which each language provides, both, I mean, not both, but for example, Python as well as Java. And that is definitely going to be very important from the perspective of your implementation. So if those aspects outweigh the benefits of performance, then you should definitely use that particular language. Many times it so happens that you are asked, you don't have that choice when you join a company, because the code is already written and you are just writing one piece of it, and therefore the language is already chosen. So you may not have that choice, but yeah, if there is a choice, you should do this kind of analysis to figure out whether a particular language is going to be used. Any other concerns for you? So I'm going to join from my other machine because my slides are on that machine. So why is Java used in mobiles if CPP is faster? Sure, I'll get to that in a minute. Let me just, okay, so looks like I'm a co-host here. Let me make myself host so that I can share the screen. Okay, so meanwhile, while these slides are coming up, why is Java used in mobiles if C++ is faster? Well, I think one of the important aspects that comes into picture when we are dealing with mobiles is this security aspect. Right? And it turns out that if you have control over uh, what all aspects, share this and I'll come back to the question. Okay. It's coming up. Okay. So you need to have some sort of a managed runtime. Managed meaning that somebody else is looking at what is getting executed so that you can control, because mobiles, etc., are going to be very vulnerable devices. Unlike the previous computers, which used to run primarily the local applications, when your machines were not always connected to the internet. So the security aspect comes into play a lot, and therefore you need a managed runtime. That is one reason. There are some other reasons also which might be related to, since these are companies, for example, let's say Android is from Google, and let's say from Mac OS also you have iOS, etc., from Apple. So the other aspect that comes into play is that you want a language which is, let's say, open source. So in or a particular company might want their own language to be implemented and so on. So therefore, those in some sense proprietary aspects also come into play sometimes in making this decision. But yeah, and on mobile phones, although performance is important, but I will also say that it's the interaction time that becomes more important. Right? It's not like your application is running in the background and that is going to give you output after some time, right? So it's the uh, not the turnaround time, but actually the user interaction that is going to be more important. Okay. Any other questions? Okay. So maybe we'll continue our discussion. So is the slide visible now? Can somebody confirm?
Yes, sir.
Visible.
Oh, okay, great. Thanks a lot. Um, so let's define the data. So we have been talking what it is not. We talked about misconceptions. So let's talk about what is it. So data structures is about organizing your data such that its storage and retrieval, that is writing to it, writing the data and its retrieval, in some sense improves the efficiency of the application or the algorithm which is using. So that's where there is a service component which comes into play when we are talking about data structures. Data structures are not going to get used directly. Those are going to be made use of for other algorithms, right? And that is going to be our important motivation or important, let's say, lesson throughout this course. How do you organize our data? And we'll see that depending upon what application demands, we might want to store data in different ways. So just to recap on what we had as misconceptions possibly, is that a data structure may get used by multiple different algorithms, right? The same data structure. Similarly, an algorithm might use multiple data structures simultaneously. Similarly, an algorithm may use different data structures and achieve different performance, right? But can still achieve the same functionality. So these were some of the aspects that I wanted to come across with. Some of the core and standard data structures, as we said that there are just infinitely many data structures and you can create new ones and so on depending upon your application. But there are some basic core data structures and that is going to be our motivation in this course towards that. The first one is definitely an array, which is a linear sequence of contiguous memory elements, right? Where I'm going to store different types of elements. I mean, it's going to be the same type in each cell. Then there are linked lists, which are going to be typically pointer-based data structures, but you can as well implement them in an array-based manner. What is important is how you access them. Of course, the underlying implementation is also going to be important, but what defines a linked list is going to be decided by what are the APIs, what is the application programming interface that it provides. That is, what are the functions that it provides. And that is going to be decided by, I mean, that is not going to be dependent on what is the underlying data structure that you use, whether you use an array or linked list or something else. That is not going to be important. When you restrict this usage to a specific place where you insert elements and specific place where you retrieve elements, then it leads to specialized linked lists, which are called as stacks or queues. For example, a stack grows in only one direction and you can push and pop elements only on one end of this particular data structure, and we will study all of this in detail. Alternatively, you can have a queue where you are inserting at the end of the list, but you are retrieving from the head of the list, and so on. Then there are non-linear data structures. So arrays and linked lists are typically called as linear data structures. There are non-linear data structures where it won't be just a sequence, but there might be multiple sequences arranged in a different manner. Those are typically trees. And there are multiple different kinds of trees which will come into play. Most important ones are binary trees or k-array trees. Then there are specific ways in which you can put the data into the tree, and that leads to more efficient data structures called as binary search trees. further versions of binary search trees or specializations of binary search trees are going to be used for heaps. So all of these are going to lead to this kind of hierarchical structure. So what I'm showing is just one tree, but there could be others which we will definitely study about. And as I have mentioned, ellipsis or dot 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 under tree, that means that there are other kinds of trees which we are also going to study. And the most one of the most interesting data structures in this case, or most efficient ones, are going to be hash tables, which are definitely going to be very useful to you whenever you whenever you design a new application. And where applicable, I think hash tables are going to be very useful. So we'll see in what situation you should prefer a hash table and how to implement those. So those are going to be looking like a two-way structure, which is a combination of an array and possibly a linked list. And finally, there are graphs, which are the most generic data structure. So when I say most generic data structure, what does that mean? When I say graph is a most generic data structure, what does that mean? Any thoughts? I mean, yes, we have not studied it, but I'm just checking with you. What do you think about it?
Every other data structure can be implemented as a graph.
Right. So what Aniruddha suggested, as well as Aniruddha suggested that other data structures can be implemented using graphs. There are other suggestions here. Let me just chat. Naimisha Sampath says can be used in a lot of places. Yes, that is true. But in this context, I meant it to be generic, meaning that it can be implemented. It can implement other data structures. Murari says we can implement any other by graph. Yes, that is correct. Kaushik says graph can be used to represent any other data structure. Yes. B19, B037, all other data structures can be replaced by graphs. Yes. Madhur says lesser rules. That is also true, that you are going to implement or specialize these in a lesser and lesser manner. And that is going to lead to a more generic structure, which is graphs. But in this case, generic means that it is going to be implementing other data sets. Good. So thanks for that discussion. All right. So this is going to be more or less how or what we are going to cover in this course. And that should help you if you want to drop the course and so on. But to make your decision more informed, I'm going to also talk about a few logistics in the next 10 minutes. Right? So the graphs are going to look like this, arbitrary processing. All right. So the learning outcomes of this course, as for 2700 we said, is that we should be able to choose efficient data structures and apply them to solve problems. We also want to design correct programs, which means that definitely we are going to emphasize on a little bit on correctness. And that would have been nice if that fourth point of prove the correctness of a program would have come into play, which is actually part of the course. But in absence of discrete maths knowledge, we are probably not going to spend time on that. So we study some sort of predicate calculus or let's say Hoare logic, which allows you to prove that certain sequence of instructions is implementing a certain functionality. So that part we are going to leave out. But otherwise, this course is going to be exactly structured the way a CS course is going to get structured. So you are going to study almost everything that a CS course is going to offer. And finally, analyze the efficiency of programs based on the time complexity. So when we say that one data structure is going to give you better performance than the other, this better is vague. And we would like to quantify that. So how to quantify is using the time complexity, which is also something which is very basic, which we are going to study a little bit in our next classes. Actually, we will study that initially before delving into the data structures. So the logistics are that, so the link is given and the slides will be available on the course webpage. We are going to meet in B slot, that is Monday 9, Tuesday 8, Wednesday 12 o'clock and Friday at 11. I have mentioned HackerRank submissions, but we'll see depending upon theory here. Anyway, we'll see if we want to do it on HackerRank or it will be Moodle, which will get used for the assignment submissions. There won't be any lab associated with this. So that is another difference with respect to the core CS course, where we have a labs 2710. but that we are going to replace with a few assignments, and hopefully you will get exactly the same experience as the CS course which is running in parallel. There is a Moodle link, and it's going to be your responsibility to subscribe to it. The evaluation is going to be, the problems are going to be either on Moodle or HackerRank. I'll confirm that soon. So we are going to use mostly C syntax in all our assignments, but we are going to use a little bit of C++. What that means is that we are going to use C++ compiler, and we are, instead of using a strut, we are going to use a class with public and so on. So if you have not studied C++, there is no problem. As long as you have CS1100 knowledge, that is going to be sufficient for you. We are not going to, for example, study templates, inheritance, or operator overloading. All of that we are not really going to study. So it's going to be all with pointers and data structures. There will be time when I'll ask you to implement something using standard template library, which will come in handy for you, because as we move to the further data structures, some of these lists, etc., we can make use of from the STL. So that, unless I say don't use STL in your assignment. And we'll also use plagiarism checking. Then there are going to be 3 quizzes, Q1, Q2, Q3. It won't be really an end-sem. It will be more like quizzes. Each one is going to be 20 marks, which means that the split is going to be 60 for theory and 40 for the assignment. So 3 assignments are going to be there, which will constitute 40 marks. The quizzes are going to be typically 1 hour and on Moodle. Right? So there are Q1, Q2 and some dates given for B slot, but our dates are going to differ a little bit from these. These are going to be synchronized with the other CS2700 course, CS course. And therefore, the dates are going to be whatever is applicable for both. We will make sure that there is no other official slot exam on that, which means that it is likely to come on Saturday or Sunday. These are mentioned on the course webpage. Request you to look at it, and if you have any changes to be suggested, you have this week to suggest any changes. Right? Depending upon that, we'll finalize the dates subject to class committee approval. There is a question, Vishnu Prasad, can we use C++ for assignments exams instead of C? We will use actually C++. So we will use G++ to compile our code. So we will use C++ without STL for all our assignments and exams. I would encourage not to use C as much as possible so that you don't get into this printf, scanf business. And I'll have to confirm with the TAs whether they will be able to, because they are going to evaluate it in a scripted manner. So it's going to be a little difficult for them to change G++ versus GCC and so on. So I would request everybody to use G++ as a uniform measure. Vikas is asking, can we solve assignments using Python if we are proficient at it? Again, we are going to stick to a particular language because it is going to make TA's life a little easy. So we should probably help them. Plus, there will be times when your test cases are going to be very large. And if you use Python, you will see the performance impact of that versus C++ code. And therefore, I recommend to use C++. You might be proficient in Python. Many of you are, and that is a good thing. It will only help you understand these concepts better, but I request you to stick to C++. Are there any recommended books? Yes, Tanay is asking this. The book is given as Wies's book, W-E-I-S-S. That is the book which I am going to follow. All the material that is required is going to be mostly coming from that book. Some of it is coming from the online material, but data structures is such a fundamental part that even if you don't have that book, but want to learn online, you can currently do it. So it's not necessary to buy the book. If you buy the book and solve exercises, nothing like it. But there is a programming course. Programming is the first word in this course. Therefore, you should do as much programming practice as possible. Again, you would know this from your experience with CS1100 that CS11 programming is like a skill development. Right? It's like learning to swim. You can't say that I'm going to read a book and learning to swim. Right? So you have to jump into water. Similarly, here also, as long as you are practicing enough, I think it will be good. Whether you refer to a book, it's going to be an added plus. Which C++ standard will TS be using to compile? Good question, Ashwin Krishna Kumar. Will we use C++17, C++11, C++14? I don't know yet, right? So definitely C++11 will be allowed. Whether C++17 will be used or not, I'll confirm by talking to the TS. At the same time, if you are using something from C++17, I personally would encourage that. And that is okay. I mean, yes, that will require TS to change their script. Maybe they will use C++17 or even 20 maybe for their evaluation script, which might be okay. So that is something which I would encourage you to use as many standard features as possible from even the newer versions of C++. That is okay. Okay, so I don't see any further questions. Just a last slide on this one. How to get the most out of this course, right? So this is something which I never thought about that I'll mention in the class. Some things are a little obvious, but since we are online, I'll mention this anyway. So what you should do? The first thing you should do is to keep your hands away from WhatsApp. I wouldn't be surprised if some of you are already doing something on your mobile. So keep your hands away from not only your WhatsApp, but also the mouse as well as the keyboard of your machine if you are joining from laptop. And that is going to be one of the best ways to focus on this, whatever I am saying, whatever contents are being shown on the screen. This is not applicable for my class, this is in general applicable, but I thought I'll mention. This course is 3 lecture hours and 1 tutorial hour. But I won't have a separate tutorial hour. I'm going to combine the tutorials along with the classes, which means that as I teach, at some points I'm going to ask you questions, solve something within the class itself. And at such times, what I have seen is that those who sincerely solve these in the class, that improves their understanding. So I would recommend that you solve questions during the classwork that we do, which means that you can just keep one small copy with you and pen. And also you can take your notes, because not everything might be there in slides. Some of the things I'll just say orally, although most of the content that is required to understand the data structure is going to be there, but some of the questions that come up that will force me to say something which might not be there in the slide. So take your notes and refer to them later. That will be helpful. And another important thing is that ask questions in the class. Don't feel shy. You are here to learn, and hopefully I will not scold you for asking a stupid question. Right? Sometimes I'll also say stupid things in the class, but that is okay, that you can forgive me for that. So we all are learning, and therefore it is all right to ask questions. Don't think that, oh, there are 100 people in the class, how should I ask questions? What will this person think about me, and so on. So don't worry about that. Your degree is not really dependent on what kind of questions you ask. So feel free to ask questions. And many times the others have also not understood. So you can definitely ask the questions. Right? And usually it so happens that a few start dominating the class. Don't let that happen. Right? Because they have some other questions, because they have understood something else, but you might not have understood something. So feel free to ask basic questions. All right, so that completes whatever I wanted to say, almost on time. If there are any questions, we can take those up now. Okay, there is a question from Arshdeep. How to submit assignments if you are auditing the course? You will also submit it exactly in the same manner. Most probably it is going to be on Moodle or HackerRank. So you will have to submit it on Moodle, which means that you should subscribe to Moodle. And if you submit the assignment, we will evaluate it, whether it is audited or credited course. So there won't be any difference with respect to that, except that the course is not going to be as part of your transcripts. But otherwise, we will treat you in exactly the same manner. You can ask questions. Only because you're auditing the course, sitting through the course doesn't mean that you should not ask questions. No, you should ask questions. We are all here to learn. It's going to be very useful for some of you. Some of you might have joined it for the replacement purpose. Some of you want to learn data structure. Some of you want a CS course on your transcript, whatever, for higher studies and so on. Some of you might have some other reasons to join the course, etc. That is perfectly fine. All of you are welcome. If there are any of your friends in IIT Madras who want to take the course, they are welcome to join, sit through the course. That is not a problem. So, yeah. Any other concerns, questions? Will CS280 Algo course be offered for non-CSE students in a similar way? Unlikely, unless there is a lot of demand plus some faculty member agrees to it. So it so happened that I decided to teach. So that's why this is getting offered. But yeah, there is no guarantee. With a good chance, it might not get offered, is what I can tell you. Right? I don't see any questions. So we'll stop here. See you tomorrow at 8 o'clock. Bye.